Assalamu alaikum, hello everybody. Today we wanted to continue what we started in the last video about the panel boards components. Last video we start to introduce for you what is the types of panel boards and what is the classification of panel boards we can find in any construction project. And what we told in last video, we told about the main distribution board or switchboard, LV switchboard, and we also talk about the sub-main distribution board and distribution board or final distribution board or load center, and the MCC, the motor control center. And then we transfer to the components of any panel board, like the enclosure, the bus bars, the main breakers, the branch breakers, control circuit and control wiring, and the measuring and metering devices. Then we give you hints about how to specify the enclosure, how to specify any component of these components. For example, for the enclosure, we provide you examples for this specification, like the sheet thickness to be 1 mm, 1.5 mm, 2 mm, the IP protection and the IK protection degree to be installed indoor or outdoor. Also the short circuit capacity of the enclosure. We talk also about the bus bars. It could be copper, tin plated, silver plated, the size of the bus bar. This again is the current density of each bus bar, and other details. And today we wanted to introduce the types of breakers we can find in any panel board. For the main distribution boards and sub-main distribution board, usually we find air circuit breaker type and MCCB, which called molded case circuit breaker. This is the most famous and common breakers type used in panel boards for low voltage side. For the medium voltage side, we can use SF6 and vacuum breakers. This related the name or the type related to the method to withstand or to distinguish the arc or the making and breaking of the contacts of the breaker. According to this, we classify the breaker type for SF6, so they use the SF6 to distinguish the arc, vacuum, or molded case circuit breaker, or air circuit breaker. All this is the method or the technique to distinguish the arc occurred in the breaker due to making or breaking the current. This is the most common types for the MDB and SMDB, and appear another one in final distribution board or load center. We call it miniature circuit breaker. This usually single phase, and we can use it three phase, but usually it's up to 630 ampere. We use this miniature circuit breaker, and only appears in load centers or final DBs, final distribution boards. For any breaker, we have usually some specification. We have to be aware when we select this breaker. Like we hear about Ampere trip and Ampere frame. The Ampere frame is the thermal current for the frame of the breaker, and the Ampere trip is a trip point or trip value, trip rated current for the breaker. That means we can find breaker frame 160 ampere, but we can adjust the trip to be 163, 125, 50. Okay, this is the ampere trip against the ampere frame. The breaker also could be fixed type or adjusted type according to these ratings. Yani you can get fixed type breaker coming from the factory or supplied from the factory with ampere trip 50 ampere, and we cannot adjust anything, just it's a trip at trip mean there is some overload occurred, so the breaker protects the circuit from this overload current. If you make the ampere trip setting, it's set to be 50 ampere, means it will trip after 50, 55, 60, 70, whatever, it will trip according to this overloading. So we classify it as fixed and adjustable according to if we can adjust the trip to be more or less according to the settings available from the manufacturer. Also, another classification to be fixed or withdrawable as per dislocate or to withdraw the breaker outside the panel for maintenance. We call it withdrawable, or fixed, we cannot withdraw it outside. This is also another classification for the breakers. Usually this withdrawable for above upper ratings like 1600 amperes, 2500 ampere, all this usually coming withdrawable. Also for the trip unit, usually for the manufacturer, they have their own settings for tripping. For example, for Schneider products, we can adjust the tripping for rating of 100 ampere, 160, up to 250 ampere. Only we can adjust up to 0.7 of the I rated. That means if the breaker is 100 ampere, we can adjust from 100 ampere up to 70 amperes only, and from 400 and above, these settings it can be 0.4 of the rated current. Means if it's 100 ampere, we can if it's 400 ampere, we can adjust up to 160 ampere as adjusting. So we can adjust the trip from 160 up to 400. This we call the trip units. Then also we wanted to talk about another thing of the specification of this breaker to be taken in consideration, which is the short circuit level. As per the calculation of short circuit, we have to select this breaker short circuit capacity. Usually there is two values for the short circuit. We call it ICU, the ultimate short circuit capacity, and ICS, service short circuit capacity. Approximately same idea of tripping and frame. Yani it can the ICU, which is the ultimate short circuit capacity, could be equal to the I short circuit ICS, the service short circuit capacity, or the ICS, which is service short circuit capacity, the point for instantaneous breaking for the at the short circuit time. This ICS could be less or equal to the ICU, the ultimate. Same idea of the frame, same idea of the frame and the tripping. Also, this frame can withstand short circuit capacity up to the ICU, but it will trip or instantaneously trip at ICS, the short circuit capacity service short circuit capacity. And these relations, all these curves for any manufacturer has his own curves, which determine and introduce a relation between time and current for tripping for overload case and for short circuit case. Also for the panel boards, we have to introduce for you, for the MCC panels, something called, we call it starters. For any motor, we have protection for the overload, and we have also starting method. This starting method varies according to the power of each circuit, and also as per recommendation of the supplier and as per the functionality of each equipment. Yani we have, for these starters types, we have direct online, and we have star delta starter, and we have VFD, variable frequency drive, and we have soft starter, and we have Autotransformer. Usually, yani by experience, up to 7.5 horsepower motors, we use this direct online, and up to from 7.5 horsepower up to 50 horsepower, we use star delta method for starting, and above 50 horsepower we use VFD and soft starters and auto transformers. But also maybe the equipment itself, it has variable speeds, so we have to use VFD from the beginning regardless power. This improves the components of the panel boards from breaker sides, yes, from breaker side. And next video we will continue some special cases for these breakers and for these components of the panel board, to explain for you what we can see in these panel boards in any construction project. Thank you.